Hello folks and welcome to Sound Codex. In today's video, I'm gonna be talking about ring modulation. This type of modulation synthesis can be achieved by simply multiplying two audio signals. So we can use two sine tones. The first one is called carrier because it provides the main frequency, the main tone. And the second one is called modulator because it modulates the first signal. Ring modulation can be achieved using bipolar signals only, so those type of signals that oscillates both in the positive and negative range. We can set the carrier to 440 Hz, so A4, and we can send the final result to our output abstraction. Let's start with the modulator set to a very low frequency like 1 Hz. This type of effect is called tremolo. So we are slowly modulating the amplitude of the signal. Now let's see what happens if I increase the frequency of the modulator. Let's say 110 Hz. So that's interesting. We get two tones, and if you take a look at their frequency, we have the first one at 320, the other one 532. Now a question may arise, that is, where is our carrier frequency? Well, with ring modulation, the carrier frequency disappears, so this is without carrier, this is with carrier. Let's take a look at what happens if I gradually increase the frequency of the modulator. So we can start with a very low frequency and raise out to a higher value. I'm gonna use phasor. Thus output a linear ramp from 0 to 1, so I can multiply its output by 220, and I can set the phasor frequency to a very low value like 0.05. And just to visualize the output value, I can use a signal to float. So we can easily see the modulation frequency. As you can clearly see, the greater the modulator frequency, the greater the distance between these two sidebands. The harmonic or inharmonic nature of the resulting sound is determined by the ratio between carrier and modulator. For an harmonic outcome, make sure to use integer ratios. Like in this example, the carrier is 4 times the modulator. If we change the modulator to a different value, so we use a non-integer ratio like this one, we get a detuned effect. We can fine-tune this modulation synthesis by ear, and we can do so by taking a look at what are good sounding ratios, non-integer ratios, because we already know that integer ratios are good sounding ones. So I can use two float boxes. The first one to change the carrier, the second one the modulator frequency. Now, what I want to do is I want to take the carrier and divide it by the modulator. So I can use the divide object. So I can take this one divided by the modulator, and this is the ratio between the two. So here 110, the ratio is 1. In case you don't know the cold, hot, inlet paradigm, make sure to watch my videos, but instead of sending this float box straight to the cold inlet, we need to use a trigger bang float. So first we send the frequency through the oscillator, then we use it to set the division, the number by which we want to divide our carrier, and then we send the bang to the carrier frequency to trigger the entire operation. So let's fine-tune the modulator to find a good sounding outcome. Oh, this is a good one. 5. Okay. Oh, this is a good one. So 2, 39, 13. Well, this is also a good one. 0.75. So we can save all these ones. 75, 80. So what we can do is we use a float number. We multiply the result by 0.75. Then we take the same number and we multiply it by 2.3913. And the other one was 5, so we multiply it by 5. Now we can multiply the first one, the carrier, with our modulator. We can take the same signal from this oscillator and multiply it by the second modulator. Output, let's take a listen to this one. So 1, 2, 1, and 2. Now, what if we take this output and we use it as a new carrier for our second modulator? So what we're doing right now is we're doing remodulation on the sidebands of this first multiplication. And I also want to listen to the fundamental frequencies. So I can do something like this. Maybe we can scale the fundamental by a factor of 0.75. Part 2 of this video is available on my Patreon page, link in the video description. Thank you so much for watching and I'll catch you in the next one. Ciao, ciao.